note that electrodes are of two types. We have the cathode and also the anode. We mentioned this thing. Sorry. All right, can you hear me now?
Yes, sir.
So we explained that the electrolytes are, aqueous or molten compounds that will decompose during electrolysis. But meanwhile, we explained first the meaning of electrolysis, and we said it is the chemical decomposition of an aqueous compound, or a chemical decomposition of an ionic compound. The ionic compound can either be aqueous, meaning it has water in it, or molten, okay, but not solid. Can either be molten or aqueous with the addition of water in it. So by electricity, so example of ionic compound, we mentioned sodium chloride, potassium chloride, copper sulfate, magnesium nitrate, We gave those examples and we showed how they decompose, how they ionize. Now, when we pass electricity into sodium chloride, it's going to decompose or ionize into its component ion, which are sodium ion and the chloride ion. And we show similar for, potassium chloride, also for copper sulfate and magnesium nitrate, that if copper sulfate decomposes, is going to give us copper 2 ion and sulfate ion, and the magnesium nitrate will give us magnesium ion and the nitrate ion. Okay, so that is what will happen to them when they ionize. Then we mentioned some other terms we use in electrolysis. We explained the meaning of electrolyte. Okay, that is the molten or aqueous solution of an ionic compound that's decomposed during electrolysis. So we show how it decomposed. And then we explain the meaning of, electrodes. And we said they are of two types. They can be, anode or cathode. They are actually conductors in the form of wires, rod, plates, that in them current will enter, and current can also leave the electrolyte. As you can see on the screen, these are electrodes, okay? One of them is anode and the other one is cathode, okay? So what are anode? They are positive electrodes, okay? The positive electrode there, they are the anode, while the negative are the cathode. Electrode can be in form of rod, plate, wire, and in them, current can leave or enters the electrolyte. Then we drew the electrolytic setup, and we said it's an assembly, that is arrangement of two electrodes, okay, in a given electrolyte, right, connected to a DC source, direct current source. So we have the electrolyte in here, and you have the two electrodes. We have wire, okay. Ions flows in the electrodes, in the anode and the cathode, while electron flow in the wire. So in electrolysis, the carriers of electricity are ions and electron. So we also explained the meaning of discharge, that it is the gain or loss of electron to become a neutral molecule. Here, the chloride ion is losing 2 electrons. Actually, it should be 1, because we balanced the equation, you have to let it be 2. So it loses 2 electrons to become chlorine gas, a molecule. And at the same time, the sodium ion gains 2 electrons to, become a sodium atom. Now, that is the meaning of discharge. This will be discharged when neutral molecule or atom will be discharged when an ion loses or gains electron. And we gave a code that reduction will occur at the cathode, while oxidation will occur at the anode, cryo. All right. Now we gave tips last time that we explained, and also this code, that during electrolysis, the cations will migrate to the cathode. The cathodes are the negative electrodes, okay? While the anodes are the positive electrode. Are you with me?
Yes, sir.
Okay. So that during electrolysis, when when they split into 2, now what will happen to them is that these ones that are the cations, they will go to this, cathode. While these ones, the negative ions, anion, they will go to the anode. And we decoded that A to A, then C to C. And also you should remember this essentially, and it's very important. You should know. You should know. So we said oxidation. We gave the definition of oxidation and reduction, which is oxidation is the is the loss of electron, while reduction is the, gain of electron. We explained this in the last, in the last lesson, right? So we're going to continue from there by God's grace today. So we balanced. Now, we want to learn the electrolysis of molten ionic compound, okay? Electrolysis of molten ionic compound. So we're also going to learn the electrolysis of aqueous ionic compound, because these are what is required in your curriculum. But meanwhile, today I'm going to be a bit fast so that we can cover as many as possible today. Then we would answer questions based on what we've learned. Now, when they say binary, what does it mean? Do you know the meaning of binary?
Like number.
Yeah, it's like number, yes. So which number?
1 and 0.
By. So how many numbers there
2.
then if you say 1 and 0? 2. Binary. So when they say binary ionic compounds are made from one metal combined with one non-metal. Example, this is lead bromide. The metal there is lead, and the non-metal there is bromine. So it forms lead bromide. So it's an example of binary ionic compound. Do you understand that?
Yeah.
Okay, another example of binary ionic compound is sodium chloride, NaCl. Sodium is the metal, and the second one is chlorine. Okay, is the non-metal. Okay, another example is aluminum oxide, Al2O3, iron chloride. Now, the electrolysis of this compound, when in molten states, produces the metal and non-metal, okay? It produces metal and also the non-metal. That is what will be produced at the end of the electrolysis. And how are they going to be produced? So we're going to see that now in these examples. Mechanism. Now let's look at mechanism of electrolysis. Look at the first example, electrolysis of molten lead bromide. Okay, we want to look at the electrolysis of this, of molten lead bromide. Now, I want to analyze it. Now, the electrolytes there will be your lead bromide. Lead bromide. What is the formula for lead bromide? It's on the screen. It is PbBr2. Are you there?
Yes, sir.
Now, what is the cation there in this compound? What will form the cation?
Bromine.
No. Lead. Lead will form the cation. They are the one with positive charge. Okay. And what will form the anion?
Bromine.
Good. So bromine is Br minus. So we have seen what the cation is. Okay, from this same compound, which is the electrolyte. It is the one that is molten. Okay. And this from it again we see bromine. All right. Now we now want to see discharge of ion. What will happen when this discharged and what will happen when this discharged? Now, this one, where is it going to go? It will migrate to the cathode, right? It's going to go to the cathode. Let's assume this is the lead bromide molten here. So the Pb2 plus will go to this negative electrode. The Pb2 plus will come here, and the Br minus will come here. I hope you understand this.
I do.
Good. Now, at the cathode, that is where we have this man, lead lead ion. All right. Now, don't forget, how do we define discharge in the previous definitions? How do we define, how do we define the meaning of discharge?
As the leftover ions in the
As the word, say that again.
the leftover ions in the electrolyte.
Loss or gain.
Oh.
Loss or gain of ion. Look at it in your note and read it out. I would like to hear that. I want to hear it from you. Read it out, the definition for discharge. That will help you understand this example more. Are you with your notes?
Yeah.
Okay, good. Go through it and read it out.
Ions are discharged by losing electrons.
Is that what you wrote?
Yeah.
Read
And
that again.
ions are discharged by losing electrons, which is oxidation.
Definition of discharge. Definition of discharge.
The loss of electrons or the gain of electrons.
Read what you wrote last week now. Just read what you wrote. You are in your finals. You have to be sharp. What you wrote down, the meaning of, I gave the definition of electrolysis, I gave the definition of electrolyte, I gave the definition of electrode, gave the definition of cathode, anode, and then discharge. The last one there is discharge. Can you go to discharge and read out what you have on discharge?
Oxidation is loss, reduction is gain.
I didn't mention oxidation. I did not mention anything that has to do with oxidation. Just read out what you wrote for discharge.
I can't find it.
All right. This is discharge. I know you were not writing notes last week, and you
I
have final
was.
exam. Why can't you do? Okay, so why are you unable to read this?
Well,
If you write down notes, find this for me in your notes and read it then. If you said you write, you've seen it. I showed you now, right?
yeah.
Okay, good. Can you please find it in the notes and read it out? If you truly are saying the truth. You did not see it still, right?
Well, no.
So which means last week you were not writing notes.
But
And
I
that was
did.
why, hold on, that was why you asked me to send you notes,
It's
because I knew
well,
you were not writing in the lesson.
but it's right in front of me.
What is in front of you?
The notes that I wrote last lesson.
But you didn't. Why did you not skip that? You skipped that. Why?
Well, I don't know.
Okay, it's all right. So yeah, this man is going to, gain electron because oxidation will occur there. So it's going to gain electron plus, 2 electrons because of the charge on it. It's going to gain 2 electrons to yield, lead Pb, okay, which is solid, okay, has gained 2 electrons. Now, what happened here is oxidation, because oxidation is the gain of, is reduction rather, because reduction is the gain of electron, and reduction normally occur at the, at the cathode. Now, we go to what happened at the anode now. What happened at the anode, right? There's going to be loss of electron, okay? So we have Pb, it has excess electron, PBr, okay? So he's losing, because he's losing electron, we're writing the arrow first. Because this one is gaining electron, we have to put plus for gaining. So this one is losing electron, it's going to be Br plus E minus, right? Now, because bromine is a molecule that is stable as a liquid, so we have to put 2 there, okay? Bromine is a liquid, all right? So unlike lead, which is a metal, this one is a non-metal. So it's a liquid. So to now to balance this equation, we need to add another 2 there. Then we have to balance the electron too to be 2E minus, right? So now, this is what happened at the anode. Okay, this is what happened at the cathode. What do we want to achieve? Now, at the cathode here, lead, has been produced. Okay, lead is what is produced at the cathode. So on this instrument, so we have to, the lead will be on the surface of this, while the bromine liquid will be on the surface of this. Then they can be scraped, dried, dismantled, removed, and then, collected. Okay, so the outcome of this example is that at the cathode, we have bromine. Bromine is produced at the end of the day. Then at the anode, sorry, lead rather, this is lead, apologies, at the cathode, lead is produced, then at the anode, bromine is produced. All right, so that is just how you would explain. Example, ask you to explain everything like this. For example, can ask you what will be produced at the cathode. Okay, that is lead. Exam can ask you what will be produced at the anode. Okay, that is bromine. For the electrolysis of molten lead bromide, that is molten lead bromide, not aqueous lead bromide. Anna, are you there?
Yes, sir.
Are you there?
Yes.
Joined late.
Sorry, sir. Sorry. Basically, there was traffic, and I closed a bit late today as well. I closed at 4.
Sorry.
I said I closed a bit late from school today. I closed at 4 today. I usually close at 3.
So you used to close at 3, but today you close at 4.
Yeah.
Okay, it's all right. All right, you can write what is on the screen. You can write what is on the screen now. Everybody, treasure, make sure you open your eyes now and write. Don't sleep while writing this time around. All right?
So can I join through another device, please? Hello, sir.
It's all right, no problem.
Okay. Please, can you scroll down?
So you should be done with this now, right?
Yes, sir.
Okay. Now you have a challenge here. Said you should write down mechanism of electrolysis for molten sodium chloride. Now you're not going to write this. I will do this as a second example. Okay, I will do this as a second example. Why this one is serving as the first example. So we have the second example, electrolysis of molten sodium chloride. Now, Treasure, can you tell me what the electrolyte is? What would be the electrolyte?
Sodium chloride or chloride.
Sorry. Can you speak louder, please?
Chloride.
What?
Right.
Just chloride.
Or sodium chloride.
Sodium chloride. So what is the formula for sodium chloride?
NaCl.
Good. NaCl. That would be the electrolyte. Good. Now, what will be the cation? What's going to be the cation? Treasure in sodium chloride. The cation will be what?
Sodium.
Say it. I will correct you if you are wrong. Just say it quickly so that we save time.
Sodium.
What is in your mind? Sodium. Sodium what?
I
And
don't
that
know.
sodium what will be the, sorry, say it again.
I'm not sure.
How about Hannah? Sodium what? Complete it for her. Is Hannah there?
Yes, sir.
Sodium what?
Sodium.
Sodium ion. Sodium ion. What is the formula for sodium ion? Who knows? Say it. Na what?
Na
Mm-hmm.
negative, an arrow.
Positive.
Oh, yeah,
Positive.
positive.
That's it. Sodium ion. That's the cation. Then what would be the anion? Somebody should tell us quickly. If sodium ion is the cation, what would be the anion? Is chloride ion. What is the formula for chloride ion?
Would it be Cl negative?
Cl negative. Good. Then the next step will now be discharge of ion. Okay. And that will be the next step. And that will happen in 2 stages or steps. We will look at what will happen at the first electrode, and then what happened at the other electrode. Now we will now say for the discharge of ion that occur in 2 stages, now you say at the cathode. Okay. So the cations, which is the sodium ion, is going to the cathode. the cation is going to the cathode, which is the sodium ion. All right. So what will happen when it get there? Sodium, you will now write that Na plus, okay, will be discharged, which is the cation. Now, this one is going to gain one electron, okay, because the charge here is 1. It's gaining one electron. That's why we put plus. And what will be produced? Sodium solid. So that's the metal produced there. Okay. Then you say at the anode. All right. Excuse me. At the anode. What's going to happen at the anode? Who will tell me quickly?
The anode is where
Mhm.
the
Continue.
the anode is negative, so the positive ones will go to the anode. Because the anode is negative, so the positives will attract. I mean, the anode will attract a positive, right?
So what we attract positive, anode is positive, yes. What we attract positive, the chloride ion, right?
Yeah.
We go there. So it's going to lose one electron. So on losing one electron, it becomes chlorine gas. Because we're balancing the equation, we have to add 2 here to balance the equation, because we can't have chlorine. We explained that sometime. Okay. So you have to put 2 here as well to balance it. Now, in the real sense, at the cathode, sodium is produced. Then at the anode, chlorine gas is produced. That is as simple as that. So the objective is just that for the electrolysis of molten sodium chloride, sodium is produced at the anode, while chlorine gas is produced at the anode as the anode. Sodium is produced at the cathode, chlorine gas is produced at the anode. That is as simple as that. Treasure, is that clear?
Yes, sir.
Please write this quickly.
I'm done writing.
How about Anna?
Yeah, me too. I've done writing.
Very good. So, I think we should have a good as a question next. They want you to answer this simple question. Why do ionic compounds conduct electricity when melting? Why do ionic compounds not conduct electricity when solid? And they want you to copy and complete, the table to show the product of electrolysis. So do question 31, 30 and 31 now. Do those ones first. And when you finish that, we move to the next. Can you do that quickly? Question 31, A, B. Sorry, question 30, A and B. Then question 31. Do that quickly, please. And complete, the table. Are you doing it? Are you working?
Yes, sir.
All right, good. And send your answer when you're done, please. Has anyone submitted?
I'm about to submit now.
Okay, please do. Our time is fast spent, so you should be able to. Has anyone submitted?
I'm about to submit now.
Okay, I received from Treasure. Because when they are solid, ions can't move freely. That's right. Because the ions are stuck on. Okay, this is good. This is good. Okay, let's see what Anna has. You deleted it.
Oh yeah, I sent you the wrong one. Sorry, sir. I'm literally about to send it now.
Are you sending it back?
Yeah. I'm literally about to send it now.
Sending it back.
Yeah.
Because the ions are free to move and carry charges and carry charge. Because the ions are held in a fixed lattice, your response is not are not complete. How about 31?
Yeah, I've done that as well. Should I send it as well?
I didn't say it. You didn't send that.
No, I didn't send that. It was not with that.
The table you are asked to fill in here.
Okay, sir. Give me a minute. Let me send it.
You didn't do it.
I did.
Yeah, please send it quickly.
Okay.
What time is fast spent?
Okay, sir. Let me send it. I did.
Yeah, please send it quickly.
Okay.
All right, good. That's nice. So you would do 32, 33, 34, and 35 as homework, please. And make sure you send that latest tomorrow evening. It's gonna help you. It's gonna really help you a lot. Make sure you send that latest tomorrow evening. It's gonna help you. It's gonna really help you a lot. Do you see that, Treasure? Please endeavor to do it, all right?
Yes, sir.
So we're going to continue by God's grace in our next lesson. Until then, do have a lovely night rest. Bye.